Good afternoon. I said we are going to revise the paper one. That is the communication I made in the morning. So I hope all of you have your papers. Have your papers with you. Paper one, that is the exam we did. This one. Okay, we go through question one. Yeah. Now, question one talks about, that is a question testing on the first topic in Form 1, which, just a minute. The question is testing estimation of length, which you did several methods, and it is talking about a piece of cotton is used to measure between 2 points on a ruler as shown. Now we have the measurement of we have a meter rule here. Then it has the measurement, which if you look, the least measurement, that is, if you can read that, that is 2.5. 2.5. The string is from 2.5 all the way through up to, if you can see that, that is 15.6. 15.6. So that is the total length of our string. If we are able to, now what we're going to do is to get the length. That is going to be, now the length of the string is going to be 15.6 minus 2.5, which will give you 13.1. 13.1. So the length is 13.1, and this length is what we are using to wrap around a cylinder. We are wrapping it around a cylinder. 6 times. So it is being wrapped around a cylinder six times. So that means now to get the circumference of that cylinder, we're just going to, we are going to have the length, we know the length of the circumference. We will take the length of the string, and then you divide by the number of turn, as always, number of turn, which we have the length of the string from our diagram. That was 13.1. We divide by the number of turn, which is 6, and that now gives us 2.18 centimeter. So that becomes the circumference of the pen. Now this is a way of approximating the length of different objects. These questions, sometimes they also ask it about if you have, maybe you're being asked, how can you measure the thickness of a piece of a paper? It can come that way, and in such a case, if you're having such question, for example, somebody asks you, you just need to take some papers, put them together to form a certain thickness, then you are going to measure this thickness from here up to there. So for example, if we had wrapped 1,000 papers together, and then they give us a thickness of, let's say, 10 millimeter, then we can get the thickness of a single piece of paper, which is just going to be the length over the number of papers, which for this case we will have 10 over 1,000, and that you will get your value there in millimeters. For example, so there are several questions testing on this. We can also remember is a topic that you did in Form 1, and you can use it. You can use a string always to to test for different thickness. For example, like the pen that I'm holding on, if you can just wrap around some string and count the number of turns, then you just need to unwind it and then you measure that length. It is going to give you that. That is on approximation of length. On question 2, that is on Kome heat 50 of water to a temperature of 80 degrees. When she added 2 mkg of water at 50 centimeter, the mixture attained a temperature of 40 degrees. Determine the value of m. So that is a question testing on the quantity of heat. And on quantity of heat, we know that heat capacity is given by mass times specific heat capacity. Quantity of heat gained, we usually get it by taking the mass times specific heat capacity times change in temperature. Now, Kome had some water here. This person has the one or some water. And then it was at a temperature of 80 degrees. She added some water. So heat, the mass of water before he added, that was 5 kg. 5 kg. And then the temperature was at 80 degrees. When she added of water, so that is for the first part. The second part is adding a mass of water, M2, that is M, at a temperature of 15 degrees. T2 is 15 degrees. And then it attained a temperature of 40. Now the average, or when you add all this, the temperature, the one that was hot, the temperature will go down, or it will be cool, and the one which was cold, the temperature is going to rise. So what we are going to have is, if you take the temperature before the addition, it should give you the temperature after adding a specific mass. And so from there, we're going to have the specific heat capacity, that is mass 1 times specific heat capacity of water times change in temperature should be equal to, now the second mass 2 times specific heat capacity times the change in temperature. Now the final temperature obtained here was 40. So change in temperature, the mass one is 5 kg. So that is 5 times the specific heat capacity times the change in temperature. The temperature was 80 initially, and then it fall up to 40. So that is going to be 80 minus 40. And then it should be equal to, now the final temperature which we are obtaining. Now we're adding the two volumes. So that is 5 plus m, that gives us the mass, times the specific heat capacity times temperature, which now the temperature come to from 15 to 40. Now the change in temperature, that is 40 minus 15. So from there, the specific heat capacity is on both sides, so we can cross it, and then we're going to have 5 times 40 is equal to 5 plus m. That one we're going to have 5 times 40 is equal to 5 plus m multiplied by the change in temperature, which that will leave us with 25. So times 25. Now from there, we are going to have, that is 200 is equal to 25 m, is equal to 25 plus, 125 plus 25 m. So 25 m is equal to 75 by 5, or 25 by 25, m is going to be equal to 3. So actually 3 kgs of water is what was added. Next question that is on a drop of oil. I think almost none of you got something on this question. Now, 100 drop of oil of density are 800 kilograms are found to have a total mass of 2 times the 10 raised to power 4 kilogram. One of the drop is placed on a large clean water surface and it's spread to form a uniform film of diameter 50 centimeters square. Determine the diameter of the oil drop. Now, this is an oil experiment, and with an oil experiment, what we always know is that we are going to have a drop, and this drop, let's say it is coming from the tube here. This drop, when it is going to fall, now it is going to fall and spread onto this surface. So it is going to spread into this surface. Let's say that is the position that it occupies. Now, the assumption that we usually make here is that this droplet is the one that once it falls here, it is going to spread out. Now, this droplet, we first assume that it is spherical. So it is in the form of a sphere. So it is spherical in shape. That is first assumption. Now, when it touches the surface where we are going to use the lycopodium powder, it is going to spread out into a thin layer, which, if I can just show here, is just going to spread out into a thin layer, and this layer here is just going to have one molecule each. So there's no molecule that is going to lie on top of the other. It's just going to be a single molecule for the thickness. So for each thickness, we just have a single molecule. Now, again, this patch or the spread out that it formed here, we also assume that it is perfect square. So a second assumption is that this the oil spread or the oil patch spread into a circular patch. So second is that the oil spread into a circular patch. So from spherical drop, when it fall here, it become circular. Now, this circular patch, we are also going to expect from this, we're going to assume that from the top to the bottom of this patch, there is only one molecule, meaning there's no molecule lying on top of each other this way, only a single molecule. So also we assume that the patch is monolayer. That means it is monolayer is one word. That means that it is only spreading out such that no molecule lie on top of each other. So now from there, from that assumption, that is what guides us on the calculation. Now, for the oil drop, we know that it is because it is spherical, we will say the volume of oil drop volume of oil drop, because it is the same drop that formed the patch, should be equal to the volume of oil patch. Now don't confuse the two. The oil drop is the one that is coming from either the burette or the pipe, this one here, and then this one here. And then when it falls onto the lycopodium powder, it is spreading out, and that spread is what we are calling the patch. So this volume here and the volume that spread out, we are assuming they are same. Now the oil drop, we assume it is a perfect sphere, and we know the volume of the sphere, that is going to be 4/3 pi r cubed. That where r is the radius of that drop. Now should be equal to the patch, and because this patch it is circular, but has some height or thickness which is monolayer. This height here, we call it the thickness now of one single layer of or one molecule of an oil. So this is the thickness. It is same as the diameter of now an oil molecule. Then this distance here, that is the diameter of the patch. So from there, we know that now this is now like a sphere. So we're going to have the volume of the sphere, we know is given as pi r square, which is the base of the oil, which is the circular area of the area of the circle, multiplied by the height or the thickness of the oil T. Now, so this is what now we relate. So if we now have to apply, we go back to the question, we are being told 100 oil drop of density are found to have a total mass of that. So we can calculate from 100 drop, we are having the total mass of 2 times 10 raised to power negative 4 kg. So that means for a single oil drop, we can get its mass. So we know that is, if 100 drop is giving us 2 times 10 raised to negative 4 kg, then we know one drop is going to give us, that is 1 times 2 times 10 raised to negative 4 divided by 100. Now that is going to give us 2 times 10 raised to power negative 6 kg. Now, this is the mass of the oil drop. This drop here that we have, a single drop now, this is its mass. So from there now, we know we only want the volume, and already we know the density of the oil. So from there, we can get the volume of the oil drop. So we go back. We go back here, and then we now have, we know volume, sorry. We now have volume is given as mass over density. Now, our mass here is 2 times 10 raised to power negative 6. Divided by our density, which our density of oil drop in kg, that is 800 kg. Now, if you do that, that is going to give you that is 0.25 times 10 raised to negative 8. It should be meter, that is in meter. So this is the volume of the oil drop. Now we go ahead with the question. The question says, one of the drop is placed on a clean water surface and it's spread to form a uniform film of diameter 50 centimeter. Oh, sorry, there is no square there. The diameter is supposed to be in 50 centimeter. 50 centimeter. Now determine the oil molecule, the diameter of the oil molecule, which rather is same as the thickness of that layer. Now we know the volume is of now the patch that is going to be the patch now has a formed as sphere, so it's going to be pi r radius of the patch square times the thickness, and what we are looking for, that the diameter of the oil molecule, because we said that molecule, they're going to be single molecules, that is now T. So rather they are looking for T. So from this thickness here is monolayer, is carrying just a single molecule. So they're asking for for this thickness of a molecule. That is from here up to there, which is same as the thickness of the oil patch. The thickness of the oil patch and the diameter of oil molecule, they're just the same thing. If we consider this distance from here up to there, we call it the thickness of the oil patch. And from our assumption, the thickness of oil patch is same as the diameter of the oil molecule. Remember, oil molecule is what make up the oil patch. So from there, we have our volume there of the oil drop, which is same as the volume of the oil patch, which is 0.25 times 10 raised to negative 8, should be equal to now pi r square t. So from there, we are going to have what we are looking for is T. So T will be given as the volume, which is 0.25 times 10 raised to negative 8 over pi r square. Now, 0.25 times 10 raised to negative 8 over pi times our radius. We have, that is the uniform filling. Now, this uniform filling is 50 centimeter. So the radius, that is 25 in terms of centimeter. That is 25. But what we are having here is in meter. So we change that into meter. That is 0.25. 0.25 square. From there, we are going to have, that is 0.25
rice in water down there and skin crush. Rice in water down there and skin crush. Now I'm giving you this chance to the groups to ask questions where you're not.
So that gives us 1.2732955 times 10 raised to negative 6. I said first, when you're doing your working, always first write the whole answer, then round off to 4 decimal or 4 significant figure. That will give us 1.273 times 10 raised to negative 6. That is in meters. So that is the thickness. That is the thickness of an oil molecule. That's now when the patch form a monolayer. That thickness of that patch, or the size of the molecule, is 1.273 times 10 raised to power 6. Always when you're going to work out these questions, the value you usually get, most commonly, they're usually times 10 raised to power negative 6. So when you get something that is not giving you 10 raised to power negative 6, it tells you that either you are wrong somewhere. It is going to give you a very, very small value that you have to work with. So this is a very common question on paper 1 that you need to practice. Get there. If that is not, usually the question come with assumption, and I've said assumption are 3. Oil drop is circular. The patch is, oil drop is spherical. The patch is circular, and then it's spread out to a monolayer, meaning it is going to form, that patch is going to form a single layer, and then that is what you get. Question 4. Question 4, the figure below show a uniform plank, AB of length 10 meter, weighing 500 Newton. 2 masses measuring 2.5 kg and 60 kg are loaded on its end. Determine the distance from the point A, where the support should be placed for the plank to horizontally balance. Here is it. Now the total length of this plank has some weight. So the weight is not negligible. And we know always the weight is going to act at the center. We're being told the total length of this from the end up to the end is 10 meter. So it means up to the 5 meter from either end, the weight is going to act because the COG acts at the center. So the weight is going to act at the center, W, and that weight is 500 Newton. Now we have a weight on side A and side B. On side A, we have a weight of 25 kg, same as 250 Newton. And on the right, we have 60 kg, 60 kg, same as to 600 Newton. Now, we are being asked to determine the distance from the point A where a support should be placed for the plank to balance. Now, automatically, this question look tricky, but from your analysis, you should expect that that way, that support cannot be at between these points, because you can see we have more weight. We will be having more weight on this side. If you put your pivot at this point, you see the moment on this side will be greater than the moment on this side, because we are having a lesser weight on this side. So what we expect that we are going to have, that pivot must be somewhere here and not here. So it is not there. It is on this other side. So from there now, once you have your pivot at this point, which we don't know exactly where the distance. Now we say we're being asked determine the distance from point A. So we say if we take from the where the weight is acting up to where the pivot we have placed our pivot to be X, then we know this is 5 meter, this is X meter, and then from the pivot up to the end, we are having it as because from here up to there was 5, and already we have taken from 5, we have taken X. The remaining is going to be 5 minus X, and that is the distance from B to where we have placed our pivot. Now, once we have taken that, now we know our turning point. So we just need to do the calculation. If this is the turning point here, if this assume this the weight on the right is not there, the weight on the left at point A, the weight at point A alone acting on this body will make it tilt in anti-clockwise moment. Assume only, that is how we handle the moment. Just take a single force and assume the others are not there. So if I take force, if I take the force due to the weight of the body, this weight alone, and assume this one and this one are not there, assume only this force was acting on this blank, then it will still, again, you can see the weight will be more down, so it will tilt in a clockwise moment. If those two are not there, and only the force of 600 Newton is acting, now the weight will move in a clockwise moment. Now, from here, you can see this is anti-clockwise, this is anti-clockwise, and this is clockwise moment. So what we know is clockwise moment is equal to clockwise moment is equal to anti-clockwise moment. Now, clockwise moment we know is 600. The force moment we know is force times distance. So we are going to have our force which is 600 times the distance, which is 5 minus X, that is the clockwise moment, should be equal to the anti-clockwise moment, which are 2. The first one is being produced by force of 250 times the distance from there. That from here up to there, that is 5 meter, and then from there up to there is X. That is going to be 5 plus X, and then we add the second moment. So now plus the second moment, which is resulting from the weight, that is 500 times X. So we have the 2, Now, when we work out this first part, we are going to have, that is 30. That is 3,000 minus 600x being equal to 1,250 plus 25x being a plus, now the second one, this is the second bracket, that is 500x. From there, we collect the like terms. We are going to have, this was 250x. So from there, we are going to have 3,000 plus 3,000 plus 1,250 being equal to 250x plus 500x plus 600x. Now, plus 600x. So we're going to have, that is 3,000. That is 3,250 being equal to, if you sum all that out, that gives you 250 plus 500 plus 600. That gives you 1,350x. Divide by 1,350, divide by 1,350. We'll get you get x as 2.4. Some decimals. So if I just round it off, it gives me 2.4. Now the question is asking, determine the distance from point A to where the support should be placed. Now from here up to from the midpoint up to where the pivot is 2.4x. Is 2.4x. So we're going to have plus 5. So that is 2.4 plus 5. That actually gives you 7.4 meters. So that is how you are supposed to analyze that question on moment. On the same question on moment, I think there's a question on Form 3, which I want to look at, touching on the moment, and we can just look at it before we go. A question that requires you to take moment from some point. Now, this is the question.